Hello, pre-algebra students. It's been a little while since we've had a video. We have tonight two purposes for this video. One, talk about applications of integers, and two, to look at an example of what we term a performance task. You've probably heard about these in other classes, performance tasks here, but we're going to be seeing them here and there in math as well. A lot more moving forward as your years go forward. So let's take a look at what a typical performance task would look like. And what I want you to do is I want you to copy down the gist of the problem, not necessarily word for word, but what you're basically doing. And I want you to pause it and try it at each juncture and see what you get compared to what I show you for what would be expected. Okay, so this is the information it gives us. A weather service records the temperatures in degrees Fahrenheit each day, publishes a report in the newspaper at the end of the week, and the graphic below shows a report from January. We have high and low for each day, Sunday through Saturday, but some of the values in here are missing. Write your answer on another piece of paper. Show all your work to receive full credit. So we're probably going to need this image again. So I'm going to do it real quick. I'm going to make sure I have it copied. Copy, because I'm probably going to need to paste it. So let's take a look at the first question. Okay, part A. David read the paper while eating breakfast, and some of the information was smudged. That's the part that was missing. Use the information below to find all the missing high and low temperatures during the week. And they give us three characteristics, or three facts, we should say. On Tuesday, the low temperature was 3 degrees colder than on Monday. On Thursday, the high temperature was 5 degrees warmer than the low temperature. And on Friday, the low temperature was 11 degrees higher than the low temperature on Saturday. So jot this information down and then go back and jot down the information from the weather report in the newspaper and see if you can figure out what the smudged answers are. And I'm going to do the same thing. So let me pause it and write out some work. And here's some work for what I would be writing out for this kind of problem. So on Tuesday, this first part here, on Tuesday, right up here, the low temperature was 3 degrees colder than on Monday. So I'm going to say, well, Tuesday is equal to Monday's low temperature minus 3. So that's -2 minus 3, which is -5. For the next part, we see that on Thursday, the high temperature was 5 degrees warmer than the low temperature. So we get the low temperature. So Thursday low plus 5 will give me Thursday's high. So Thursday's low is -1 plus 5 is +4. So the Thursday high temperature was 4 degrees. Not very high at all. Clearly a very cold place. On Friday, the low temperature was 11 degrees higher than the low temperature on Saturday. So we've got our low temperature Saturday. Friday's low was 11 degrees higher than low on Saturday, which was -8, so 3 degrees. So that would be a good example of a performance task question. Let's continue on to part B. Graph each of the high and low temperatures on a number line. What is the difference in the highest and lowest temperatures? So again, I'm going to need my information. And let's bring it in. Okay, had to go get that information. So graph each of the high and low temperatures on a number line. What's the difference in the highest and lowest temperature? So draw yourself a number line and graph away. So this is looking at, do you understand the relationship between integers and how they fall on the number line? And so let's go ahead and give them a display for that. Okay, so the question says, or this section says to graph each of the high and low temperatures on a number line, which I did with red dots. The only place where I would say is something that we need to figure out how to deal with is right here where we have 2 3s, because we do the low temperature on Friday and the high temperature on Sunday were both 3s, so I stacked them, and that makes it so you can still see that there are 2 of them. What is the difference between the highest and lowest temperatures? Remember, when we take the difference between the highest and the lowest, we're doing integer subtraction, so we're subtracting a negative. And remember how that works. Keep, switch to a +8 in the parentheses. So really that's just 12 plus 8. There is a 20-degree difference. And we would probably want to start thinking about writing this stuff, your answers, into sentence form. There is a 20-degree difference between the highest and lowest temperatures. And that little text box, let's make that text a tad smaller. And this could, I guess this could be something that students might do on an iPad, but I doubt it. Well, there's a 20-degree difference between the highest and lowest temperatures. Moving on to part C. Find the average high and average low temperature for the week. So again, let's get our image. And when we do this, what we're doing here is we're adding all of them together. We remember average is adding all of them together and dividing by how many there were. Now there are 7 days in the information that was given to us. So we need to add all of the numbers together and then find out the average, the mean for each one. All right, I'm going to pause it, get some of that information together, and then you can do the same and see how we compare our answers. Okay, let's take a look at how we did here. Hopefully you got similar answers. I didn't quite finish. I decided to finish it off, and I'm going to use a calculator to do this division. Because sevenths are not very convenient fractions, that's one. Two, when we talk about temperatures, we don't usually talk about them in mixed numbers, so a mixed number doesn't really make a lot of sense here. And finally, three, they're temperatures. It actually makes better sense to be able to give like a decimal, even though we know we don't think of temperatures in decimal format or decimal values of degrees that are, that we don't go that down to that kind of detail. It's still easier to think about than a fraction or a mixed number. That, you don't walk around saying, man, it's cold in here. It's, 51/7 degrees in here. That would be really weird. Okay, so 51/7. Use my trusty iPhone calculator. I didn't bring any other kind home. Is 7 point, we're going to round it off to the nearest tenth, 7.3. So the average high temperature is 7.3 degrees. And then we have negative 15/7. The average low temperature is negative 2.1 degrees. I want you to notice a couple of things. One, I understand that I need to put this squiggly equal sign. This means approximately equal to. It does not mean exact because I can't give an exact decimal for this unless I use repeating bar notation because sevenths are repeating decimals, and same thing here. Now let's go ahead and state our answer in a sentence. And I put my sentence down at the bottom of the screen because it's a little crowded on this particular screen. The average high temperature is 7.3 degrees. Oop. I meant to use my pointer tool. The average high temperature is 7.3 degrees. The average low temperature is negative 2.1 degrees. I had to show that I knew how to find an average. I also had to show that I know how to add integers. And if you notice here, what I chose to do is add all the negatives together first. 8, 9, 10, 11, 12, 13, 18, 19, 20. And then add the positives together and then add them together before I divided by 7. So we only have one part of this left, and let's take a look at it. Because of the cold temperatures, David decides to make scarves to sell at a craft fair. It costs him $5 to make each scarf, and he sells them for $12 each. He sells 28 scarves at the craft fair. What is David's total profit? So this first requires that I understand what profit means. That's the money made above the amount of money spent. So if you have spent money, you have to recover that. And so when we say profit, that's what you make beyond what you are actually spending. Okay, pause it and give it a shot. See if you can figure out David's total profit. I'm going to do the same thing, so pause it or you can't turn back. So it costs him $5 to make each one. That's a negative 5 because it's a cost. It's a cost. All right, and it costs $12, or he sells them for $12. So that means that in this problem, we have to acknowledge that he had to spend $28 times negative 5, but then he makes $28 times 12. And we're going to be able to add them together. So really, we could think of this several different ways. You could have said 28 times negative 5 plus 12, because the net amount made from a scarf is $7. You make $7 from the scarf because you have to spend that $5 out making it in the first place. And this is actually a great lesson in the way business works. Nothing that you sell is free. You got to be able to make it first. So you got to have money to spend to begin with. So 28 times 7, let's see, that's 20 times 7 is 140. 8 times 7 is 56. 140 plus 56 is, I believe, 196. And so that's our final answer for that problem. Although, I also could have thought about doing this by doing 28, what you actually see right up here. Here, 28 times negative 5 plus 28 times positive 12. Well, this would be negative 140, I believe. And 28 times 12 would be 336. And so then I'd have to add negative 140 plus 336. Now let's do this with the counting upward, or the canceling out method. 140 of these cancel out 140 of these. So that means that I have how many left? Well, I'm going to count up. From 140 to 200, that's 60. From 200 to 300, that's 100, so 160 plus 36, 196. So it doesn't matter which method I use, this first one over here, the second one over here, I get the correct answer to answer the problem. And then, of course, I have to put my answer in the form of a sentence. So let me pause it and do that. David will make $196, $7 per scarf after the cost of making the merchandise. And that is an example of a performance task. So a performance task is meant to be, can you take your skills and apply them? And that's what we did with applications of integers. All right, I'll see you guys in class.